Hello, everybody. Welcome to Robot Builders Night Virtual for February the 18th. We've got the usual agenda of some DPRG announcements, then a queue, and then we'll move to open mic. So DPRG announcements, just a reminder that this Saturday, the 22nd, we will have the DPRG February meeting, and it will start at 10 o'clock. Well, nominally 10:15-ish at the Dallas Makerspace, and we'll have remote dial-ins as usual. And the agenda will have a vote to elect new officers, and then Doug Parody is going to present a talk on how to design PCBs using KiCad. Very excited about that. I need to design a PCB, and so looking forward to that. I think it's probably going to be a popular talk. We've advertised it on Meetup and in the Makerspace, so I hope we have enough pizza for lunch. And then we're talking just looking a little further out, April 26th. We're thinking about having so April 26th is the monthly meeting for April, and we're thinking about having a robot expo at the Dallas Makerspace. It coincides with the Dallas Makerspace open house, so we thought we'd maybe do a Moon Day kind of exhibit and show off our robots, and hopefully try and get Roby, the 7-foot-tall robot, working for that. So that would be exciting if we can do that. And then yeah, so that's it for DPRG announcements. Is there anything anyone knows of that I forgot? Late March, we'll have another Robot Builders Power Lunch, like we did in December. So that'll be, the first quarter Power Lunch, and we'll meet at Ford's Garage, which has a space that we can all occupy. Okay, that's it for DPRG announcements. So with that, I'm going to start the queue with Trish. Trish, what have you got?
Hi, for anybody who doesn't know me, my name is Trish, and I am a certified judge and judge advisor for VEX. So I go around to tournaments, and I either judge at tournaments around the country and at Worlds every year, or I run the judging. So the first thing that I wanted to tell you guys about is that our high school is hosting the Regionals Championship for Region 5 for Texas on March 1st. And it's in Lucas, Texas. And I will put the details in Discord, but I wanted to invite you guys to come if you want to come see the 40 best teams in Texas battle it out for spots at the World Championship. And the second thing is that I was wanting to see if I could get your help, like what you guys do with the FTC teams, where you meet with them and kind of listen to their presentation and take a look at their engineering notebooks. Because one of the challenges our teams have, we've got 7 teams right now that have qualified for regionals, and I'm expecting most of them to take spots for Worlds. And we usually dominate in Texas and dominate in the region, but then once we get to Worlds, we kind of struggle with some of the competition that comes in from other countries. So we'd love to get some feedback from you guys since you're industry experts.
It might be overstating the situation to say that we're industry experts, but that's certainly something that we have done for FTC, for Kareem's team in FTC, and I think it's entirely within the sort of scope of what DPRG does in its outreach activities. In fact, three of us, Mark and Doug and myself, were on a call for an hour and a half or so last night with Kareem's team, doing just that, listening to their presentation, critiquing their slides, and then they left their notebooks with us for us to comment. And so I would support that. I'd volunteer to participate in that. And I think if you post it on Discord, you'll probably get some more, but some more contributors. But can you tell us a bit about, do you know anything about how VEX might be different from FTC? A number of us have experience with FTC, but then a number of the members actually volunteered to judge at VEX Worlds back in about 2010. And it seemed to me it was sort of the same thing, give or take, but do you want to talk to that?
Yeah, so it is a lot of the same thing. So technically, when they're doing the communication part of their robotics program, that's not supposed to be presentation. It's actually supposed to be an interview with open-ended questions. But most of the kids, they know so much about your robots. If you just ask, tell me about your robot, they'll talk for 20 minutes. And so so there's a rubric that we're supposed to score them off of that just kind of talks about how is their engineering design process, how is their build, how is their code, how do they approach and solve problems with their build, how do they handle conflicts, how do they do their project management, like stuff like that, just to score them on how much they're actually learning about the engineer design process. And then their notebooks, from what I understand, are pretty similar. It's just they're putting everything in their notebooks. They're putting in where their ideas come from, their research, their brainstorm, how they make their design decisions. They talk about their program management in them. Almost all of them use Gantt charts with long-term goals and short-term goals, and how they evaluate problems and solve problems. And some of the notebooks are already 1,000 pages long. And yeah, I know.
I hope they don't expect judges to review that.
So no, that it's also a thing where they give us a rubric where we're just looking for specific things just to make sure that they're actually following some sort of design process, what they're learning, and to make sure that they're doing all the work themselves. In VEX, adults are not allowed to help. They're allowed to ask questions, and we're allowed to give them like suggestions and kind of help them, but we're not allowed to touch robots. We're not allowed to write their notebooks. We're just allowed to kind of guide them, and maybe kind of they can bounce stuff off of us, but we're not allowed to help.
And in the interview where the judges talk with the teams, is that how does that work? Can you describe that process?
Sure. So when we go to tournaments, all of the teams, they have the option of having an interview if they want one of the judged awards. And all of the judges that we've got, they're trained. They usually work in pairs. And it depends on the tournament. Sometimes the judges will be assigned teams and they have to go find teams throughout the days. I'm sorry, throughout the day. And it's supposed to be around a 10, 15-minute interview. And you're just looking for all of those things on your rubric. And you're only allowed to score them based off of what they say, not what you think they probably know, because it's supposed to be an exercise of them learning how to communicate what they're doing to other people.
So it's a purely an interview Q&A on the floor where the robot pits are.
Yep.
Okay. Well, that's interesting. That's different than FTC, where they have a formal presentation. They do 5 minutes of craziness, 40 slides in 5 minutes, which is just nuts. And then 5 minutes Q&A, and then 5 minutes for judges to deliberate, and then you move on to the next. So different, sounds reasonable. I think
but they do at FTC, they do something similar to what Trish just mentioned, but it's usually, so the interviews that the judges do winnow the field So, and then the ones that become potential candidates for an award, that's when they come out on the floor and talk to the team and look at the robot again.
Good point, Doug. Yeah.
So it is included.
Yeah.
I actually like that part better. Because the first part is, oh man, it is crazy. Yeah.
Yeah.
But
well, what, Trish, I want to suggest, why don't you put something on Discord?
Okay.
And
some links, maybe Trish.
A what?
Some links, you know. Yeah,
sure.
you know, so I can think of one for the contest, whatever it is. So you know, it's nice to know what they're trying to do.
Oh, and, I've got a link for the game, a link for the rubrics, a link for like sample questions and all that.
That would be good. That would be, that'd be a big help.
If you've got a link for the game, you could post it in the chat here, and we can like have a look at it, or you could like play it and share it out, whatever makes sense. Because we just saw the FTC game yesterday.
I have a question. Does the do you have a certain hardware that you have to build with, or can you build with anything?
No, we have to use VEX parts. So there are certain they're just certain things that they have to use, and they want it to be fair, where it can't be like a pay for play. So they're just like, you have to buy your stuff from VEX. This is what you can buy. These are, and you get like size limitations and weight limitations.
Do they allow like custom machined parts and 3D printed parts and that kind of stuff?
No, they're allowed to 3D print just for decoration, but not for any parts.
Oh, okay. Interesting. That's a difference from FTC.
Yeah, so it kind of, I think the kids would like to be able to use whatever they want, but it also is pretty cool how creative they can get with what they're allowed to have.
Yeah. Yeah. Interesting.
How about in the software? Is there like a software structure you're supposed to use, a coding style, or?
No, they all do their code a little bit different. There's actually one of the kids, he's like a 17-year-old kid, and he's already written his first white paper on system controls. All right, so it is in the link now. Let's see. I could try to share my screen. I don't know how.
So there's a box with an up arrow down at the bottom of your screen. If you click that, it will give you the choice of sharing a tab, a window, or your screen. Usually, I'd share the window that's going to do the display, and then click over to that tab and
oops.
By the way, for anybody who doesn't know, Trish came out to our Robo Columbus contest in
that was super
fun. November, and so that was pretty fun. That was really a fun day.
We got
okay, where's the button?
Really good weather.
It's the square button with the up arrow down at the bottom of your screen.
Oh, okay. I keep getting an error message when I do that one. That's what my problem is. Okay, share that. Please share.
Well, there we go.
Okay. Oh, and we can learn about nail polish while we wait for the video.
Polish is a hybrid of makeup.
Welcome to the 2024-2025 VEX V5 Robotics Competition and this year's game, High Stakes. High Stakes is played on a 12-foot by 12-foot field by two alliances, one red and one blue, made up of two teams each. The game's primary scoring object is a plastic ring. Rings have an outer diameter of 7 inches, an inner diameter of 3 inches, and a thickness of 2 inches. There are 48 rings on the field, 24 red and 24 blue. There are also 5 hexagonal mobile goals that can be used by either alliance. Mobile goals have a maximum diameter of 10 inches and an overall height of 14.5 inches. Points are scored by placing an alliance's rings onto 1-inch PVC pipes called stakes. There are 10 stakes located around the field. 5 stakes that are part of the mobile goals, which can fit 6 rings each. 2 wall stakes, which can also fit 6 rings each. 2 alliance wall stakes, which can fit 2 rings each. And 1 high stake on top of the ladder, which can only fit 1 ring. Rings that are scored on stakes are worth 1 point for that ring's alliance. The highest ring on each stake is called the top ring and is worth 2 additional points. Matches begin with a 15-second autonomous period, where robots operate without input from their drivers. Robots begin with 1 ring as a preload and must stay on their side of the autonomous line. Alliances also have the opportunity to earn an autonomous win point by completing a certain set of tasks during the autonomous period. The 1-minute 45-second driver control period begins once the autonomous bonus winner has been determined. In high stakes, object possession is limited to 2 rings and 1 mobile goal. However, rings that are scored on stakes do not count towards this limit. And rings can be descored from any neutral stake at any time. At the end of the match, robots can earn additional points by climbing the 4-foot-tall ladder. Using the first bar of the ladder to get your robot off the ground is considered a level 1 climb and is worth 3 points. Passing the first bar gets you to a level 2 climb and is worth 6 points. Getting the entire robot above the second bar is considered a level 3 climb and is worth 12 points. Note that the ladder has 4 sides, but there are no Alliance-specific climbing locations. Robots may climb up any side that they want. One more thing. At any point during the match, mobile goals can be placed into the 4 corners of the field, which will modify the scores of both alliances. 2 of them are positive corners. If a mobile goal is placed in a positive corner, all rings scored on that mobile goal will have their point values doubled. The other 2 are negative corners. When a mobile goal is placed into a negative corner, all rings that are scored on that mobile goal will effectively be changed to negative point values. They are now worth 0 points and remove an equivalent amount of points from the Alliance's other scored rings. High stakes can also be played in Robot Skills Challenges, where one team competes against the clock, and the collegiate-level VEX U Robotics competition, where teams design 2 robots using advanced materials. Check out the game manual, or talk to your REC Foundation representative for all the details. Official rules and game information for high stakes can be found at recf.org or vexrobotics.org.
Cool. Thank
Yeah.
you for sharing that, Trish.
Yeah, it's a fun game this year.
Yeah. Just parallels all over the place with FTC.
Yeah.
Well, cool. Yeah. So what kind of time frame are you looking for a review?
After it's like sometime in March, if possible.
Oh, yeah. No problem.
Okay.
Yeah, I'm sure that some of us will participate in that. I'll volunteer, but I'm sure there'll be others.
Okay.
Cool. Well, thanks.
Thank you. Thank you for letting me share.
Thanks,
Yeah.
Trish.
Trish, are the teams local? Like, I mean, I don't know, North Dallas area, or are they all further out?
So the state's divided up into regions. So our region is Region 5, and we're like the Dallas-Fort Worth area, and then we go we go west. I don't remember what city we go to, but since Texas is one of the biggest, they've got the most teams out of Texas. We're divided up into 5 different regions. So there's 5 different parts of Texas. And then the entire program, there's 42 countries around the world that participate in this program. There's about 25,000 teams that are registered. And so they're all fighting for spots at Worlds. So at Worlds, there will be 800 different teams that compete here in Dallas. And then this is the last year that Worlds will be at Dallas.
I remember when we did Worlds. You probably helped do Worlds for VEX, didn't you, Doug?
No, I didn't actually do judging at that time. That's about the time I joined DPRG.
Okay. Yeah, it was a huge. I mean, it was down at the Dallas Conference Center, and it was huge.
Yeah, it's big. It's really cool.
Yeah. All right. Well, good. If there's no other questions for Trish, we'll move on to Fernando. Okay, Fernando, what have you got?
Hello. I kind of just wanted to present the swerve module that we've been working on.
Oh, yeah.
Yeah, unfortunately, it won't be going on the robot for regionals since we just ran out of testing time for it. But I've been working on it, I think, since April of 2024. So it's been a long time in production. So it's got the TPU tire here on the wheel. It uses the bevel gears here to drive it from the motor that's up here. It's on a 25-to-1 gear ratio because earlier we tried it on a 9-to-1 and that just didn't have enough torque for what we needed. And then it has the servo here to control the yaw of the wheel. And then it has this through-bore encoder to know where the wheel is facing, and it moves with the wheel. And then it's driven, the direction is changed by this belt that's right here. So I don't have any way to actually test the code that we've programmed for it, but I can run it off of just Servo Programmer that has a test mode.
Oh, so it's continuously variable.
Yeah, so we went for a continuous mode because whenever we're in the normal RC servo range, we don't have enough range to fully turn around. We just decided to take the loss and go with the continuous rotation. And then for the motor, just powering it directly off of a battery. So I've been trying to stall it. I haven't really been able to, which is what happened with the 9-to-1. We were able to stall it pretty easily. And then with testing, we were able to make the gear skip, which is why we added change to this design for the forks. We're able to now put a screw into the axle that's in the center to squish it together so that there's no gear skipping. And then
how does the drive from the motor to the wheel work, Fernando?
So then it goes from the motor through an axle adapter, then feeds into a 30-tooth pinion gear, spur gear, and that goes over to a 20-tooth spur gear. Goes down through an axle that's right here, and it goes through a bevel pinion gear that then meshes with this hub gear here.
Oh.
I'm not sure if you could see it around there. There's the pinion gear. A little hard to see.
Oh.
I don't have any CAD on me right now, but I could show easily. Yeah.
Cool.
So is the serve mechanism, is it belt driven or is it gear driven?
Gear right here. And there's the bevel, the pulley here with the belt.
Oh, okay. So it is belt driven. Okay.
Belt.
So when you yaw the wheel, does it rotate it also because it's off axis, or?
Yes. Coaxial. I don't know. There's some term for it, but yeah, whenever you turn it, the wheel ends up turning a little bit.
Okay.
So we kind of have to make up for that. Whenever we decide to turn, we kind of have to do some kind of offset for the time, make sure we're already stopped. The wheel has stopped moving before we can start driving.
Makes sense.
Yeah. And another thing. Oh, sorry.
Oh, I was just saying it makes sense.
And then now I'm actually able to back drive this. Before we were having issues with there being too much friction in the design that we weren't able to actually back drive it, but now we're just pretty easily back drivable. That had to do with over tightening screws here that would compress the axle, and then having too much tightness between here or offsets in the level of the axle. So there's been a lot of iteration that we have to do with the design to get it to properly work. So now we're finally getting at a stage where we can probably put it on a chassis, but unfortunately now it's regionals time. And then this is where we advance the worlds because they removed our state competition. So yeah.
Yeah, that sucks.
Yeah, I just wanted to show this off. Since...
How many swerve drives would a robot have?
So you could pull off one, but you need to have an extra like turning thing, so it's not the most optimal. You could probably go with a minimum 2, but we're thinking of doing 3 for counterbalancing issues that we've had with our large arms and the amount of weight that would put on one side of the robot.
And would there be additional like omni wheels like elsewhere under the chassis to support the weight of the robot, make sure it didn't like overbalance or anything?
Not with the 3-wheel design. With the 2-wheel design, we did have a set of omni wheels at the very front because they were at the very back and opposite sides. So it's kind of like a trike, the design that we'd be going for.
And then, so it lets you. I get that it lets you translate the chassis in any direction without really significantly rotating the chassis, right?
Mm-hmm.
Wow. So I see. So I guess you got to. Would you envision rotating the chassis ever, or would you always keep it in the same orientation?
I'm not even sure if you can turn them. We haven't had enough chassis testing. We did it once, but it was with a single one. So I'm not entirely sure if the chassis turns at all. I could be wrong on that. I haven't had much testing with it on a chassis. I'm not sure if the chassis ever turns, if the wheels themselves are doing the turning.
Right. But if you pointed all 3 of the wheels
you put them different, yeah.
circle that they're centered on, then it could be rotated. I'm just wondering what the dynamics of the robot movement would be in play.
I don't know if we'd ever have a need for that in our game, but I mean, we haven't delved much into it. I think this is the first time we're doing a full swerve chassis. Before, we've done single swerves with omni wheels on the sides or something. And we've done, what's it called? Differential drives. But we've never, I don't think we've ever done a swerve like on this small scale.
Huh.
Yeah.
Oh, that's really interesting.
Yeah. I think that's all. And then the carbon fiber for the style points.
You guys love carbon fiber.
How much does that apparatus weigh? About, yeah.
About maybe 2-3 pounds. I'm not exactly sure, but it's not too heavy, but it's definitely hefty.
Mm-hmm.
Wow. Cool. That's innovative. That is really innovative. All right. Anyone else got any questions for Fernando? If not, thank you, Fernando. Appreciate that. That was interesting. We'll move on to Ray.
Okay. I've been playing around with OpenBot. Let me see if I can switch my camera.
Oh, yeah.
Options. Settings. Video. Okay. Anyway, I've got a really slow speed camera here. This is the platform. It's an older make block platform. It's got the 25 millimeter motors with encoders on the back. They're Pololu encoders. I usually don't use an ultrasonic, but that's what they had as one of their sensors. The rat's nest back here is an ESP32 with a TB6612 motor driver. And so these two pieces here are 3D printed, the sonar holder, and this is actually a phone holder. So this pulls up and is spring loaded. And they give you the, I use the STL files that the OpenBot website provided. Anyway, so typically, the phone would, clip into this thing, and you would face it so the cameras on the phone are aligned, to the center of the robot in the holder. So let's see here. Got to switch. One other thing here. Only got so many plugs on this laptop. I got to yank the camera. Hold on a second. Come on. Hopefully it's back. Let me see if I can get the camera going again. Oh, I don't have a mouse. Okay, settings, video, see. Oh, come on, camera is off. Ah. Okay, it's back. Okay, I was going to try to demonstrate some of the things I was able to get to work. I don't know if this phone is also my hotspot, so I don't know if this is going to work or not, but I'll give it a try. Okay. Okay, so this may not work so great. Okay, this is the screen that you get on. Of course, it's just whited out. Come on. Anyway, there are different things to select on the screen. Let's see which one here, legacy. So that's actually showing, on the camera what the phone would see on the robot. And one of the things that you can do, there's different models that you can choose from. This one, there's a selection for MobileNet version 1-300, and you can have that track different things. So one of the things that they show is it tracking a person. So if I turn it on and show up as a person on the screen, Oh. Yeah, okay, I'm not connected to the robot yet. I forgot I've got to turn on Bluetooth. Because that's how the phone connects to the ESP32. So hold on a sec. See if I can get that working. Bluetooth.
So Ray, it's running MobileNet on the model, the MobileNet model on the phone.
Yeah, on the phone.
Okay, gotcha.
Yeah. Okay, so it's, you can't really see it, but I've just connected to connect. Come on. Okay, there we go.
So is there like an ESP32 on the robot that the phone talks to?
Yes, it's through Bluetooth, a Bluetooth connection. Okay, so let's see if I can get. Okay, I'll try free roam. Yeah, nope, wrong one. Hold on. Legacy. See if I can get this. This is the worst way to demo something. Okay, yeah. Okay, so let's see if I can get you to actually see that. That's one of the screens that you can connect to. So once you get Bluetooth connected, God, this works horribly. It basically shows up which sensors you have. So in this case, I have there's a voltage divider that senses what the battery voltage is. There's a sonar sensor. The wheel odometry, I have front wheel odometry because I just have a caster in the back. There are LED indicators that are more like turn signals or directions. So at this point, the battery reading is 9.9 volts. I don't have any speed because my wheels aren't spinning, and the sonar reading is kind of bouncing around there. That's like 79 or 80 centimeters. So if I hit, there's a forward, backward, and stop. If I hit forward, down here, the wheels should spin, and I don't know if you can hear them or not, but they're spinning. And the RPMs are showing up on.
Yeah, I can see the motor. I can see the wheel wobbling a little bit as it's.
Oh, okay, yeah. So it's showing the speed in RPMs and what the sonar reading is reading. If I hit stop, it stops. So that's one of the things. The more sophisticated thing. Let's see if I, yeah. Okay, so in this one, it's actually showing what the phone is seeing on the phone. And there's several different models that you can choose from, but it seems like the one they have the most support for is MobileNet version 1-300. If I turn it on, it will look for a person and try to track a person. So you probably can't see that worth a darn, but anyway, it's thinks it's seeing a person in there. It's like 50%, 51% confidence. And it tries to steer the robot towards the person. And if it gets too close, it stops. So, and it's using the sonar reading to determine, when to stop. And it says how many, usually how many, is it frames per second on this one? Nope. Okay, it's not telling you that. Well, yeah, it is. It is and you can choose like the. I'm going to turn that off because that's making a lot of noise and you can't really see anything. Anyway, so it's telling you how many times or how many milliseconds per frame using either the CPU or the GPU. So it's kind of neat, pretty powerful. One of the one of the things that you can do, it's like block programming, so you can make your own custom control and load that down into the phone and run that basically. Let me see if I can show that. Oop, no mouse.
What would this custom control thing be? What sort of a thing?
You can incorporate one of the models for it, and in, like, let me see here. This is the screen. Okay, so like MobileNet version 1-300, there are, I don't know if there's 300 models in it, but you can, like, tracking a person is one of the things you can do. You can track, like, a cat or a dog or a vase or, pretty much anything that, there is to track in the models for MobileNet version 1. And you can use other models. It looked like, trying to think what the other ones are. Different versions of YOLO. If this supports all the models that it lists, it's a pretty large number of models that you can use with the phone to control the robot. Let me see if that's not the screen I wanted.
Hey, Ray, can you retrain the MobileNet, the back end of the MobileNet model to target different classifications?
It looks like
Or
you can. They've got a method for training. So you actually use the phone on the robot to take a bunch of photos and use those to create a model with.
Okay.
Let's see, send model. Okay, yeah. Oh, I think that was online where I saw where all the different things that objects. There it is. Okay, so like starts out person, bicycle, car, motorcycle, airplane, bus, train, truck, boat, traffic light, fire hydrant, stop sign, parking meter, bench, bird, cat, dog, horse, sheep, cow. Must have a agricultural theme there. Elephant, bear, zebra, giraffe, backpack, umbrella, handbag, tie, and it goes on. There's just a list of
125 targets. So
what's that?
I think it's 125 classifications. I don't think you want to read them all.
Yeah, it's quite long. That's what I was thinking. Maybe it's 300 classifications.
Yeah. But
anyway.
No cones, no traffic cones.
No, not a cone in that one anyway.
But it sounds like you could provide your own images and train to a specific object.
You're right.
Yes.
Yeah, I mean,
you should be able
pretty
to.
much what you do with all the models in a sense.
Yeah.
And it's training on board the phone itself? Or are you training on a third-party website somewhere?
I think you're training on a third-party website. I haven't looked into that too much, but as far as I can tell, it looks like it's, you download the models to a website and try to do the training there. And then looks like it provides a barcode for a link, like the what is that thing? Oh, the MaxCam. MaxCam did the same sort of thing.
Right.
You create a model, provides a barcode for you. You just scan it with the camera and download it and run it.
Okay.
So it seems pretty versatile.
Yeah, this OpenBot project sounds even more comprehensive than I thought when I read the paper.
Yeah, and I can go to some of the things. Oop, don't have a mouse anymore.
Hey, Ray, just on the side, can you repeat what the motor driver was?
It's a TB6612.
TB6512.
No, 6612.
Okay.
Yeah, Polulu put it on a little, 10th-inch spacing like board that you can mount into,
Okay.
the prototyping boards. I'm trying to think who else you can get. You can get them from.
I'll look it up. I just wanted to know because I've been looking for a motor controller chip. I'm a little I'm a little unhappy with the one that I'm using right now. Not because it's a bad motor controller, but because it's not doing it. I'm trying to make my PCBs smaller, so I'm looking for something small.
I got my 6612s from AliExpress. They're dirt cheap and they work fairly well.
Yeah. They're much better than like an L298.
Oh yeah, because they're Moss, so they're way better.
Yeah. Less voltage drop across the device and more on the motor, and it's got a pretty wide range, not as wide as the L298, but it'll go up to I think like 13.5 volts, so you can run a 3S battery on it.
Okay.
Without any issue.
Yeah, I didn't mean to distract you. I just was, you mentioned it and I just wanted to capture that before.
Yeah, I've used them a lot. They're pretty, pretty robust part. I think they have thermal monitoring, so if it gets too hot, it'll shut itself off. And
there's 2 H bridges in the package, and you can parallel them up safely. The data sheet tells you how.
Yeah, I guess that'd be, well, it's not really considered bridging. But you can do that if you want to get more current out of it.
The manufacturer says it's perfectly safe and recommended if you need more current.
Yep.
I did it on my outdoor robot. I still burned it out, but I did it on my outdoor robot.
Oh, really? Wow.
Then I went and bought a 40 amp H bridge.
Oh God, yeah, that's huge.
That's not.
Let me see if I can do some things. I don't know if yeah, I think I'll try that. Let's see if we can do that. Okay. Let me see if I can present. Okay, I'll try home. And that one. Share. Okay, let's see if I can pick one of these. Can you see that?
Yep.
Okay. Anyway, so this is just the laptop with the block programming on it, and one of the things that you can use is like input from the phone camera. Oops. Okay. Swipe to end. Come on. There we go. To be able to program it. You also have access to other things in the phone. If your phone has a gyro, like mine has a gyro, it has a compass and an accelerometer. I'm trying to think what other things you have access to. Oh, if you want to, I haven't tried it, but you can also connect, between the phone with USB, between the phone and the ESP32. And I'm not, I tried that. I couldn't get that to work. I'm not certain why. But Bluetooth seemed fine, and then I didn't have to make connection to it, and it seems like it maintains the connection. I don't know if this particular video. Did you see that?
Yeah.
Yes.
Okay.
Where's the robot?
Show me the robot. Okay.
Oh yeah.
Yeah, so there it's using MobileNet version 1, and it's following a person. And
So their design is comfortable with low resolution wheel encoders, I see.
say that again.
Their design appears to be comfortable with low resolution wheel encoders. Those are TT motors with 20 pulses per revolution on them.
Yeah,
that little breakout.
That's one of the options. Yeah, there's also a 520 motor. It's got several hundred counts per revolution. So it yeah, so there's several different motors that you can do. I actually changed the TT motor resolution of 20. I think I've got 506. It's like a gear reduction of 46 to 1, and I think I want to say these encoders have 11 counts per revolution. I also had some 20 count ones, and you can't really, at least I can't see the difference between the two. So these may be 20 count. I don't know. Yeah, one of the other things you can do is you can call out a point and have it try to follow. It's like you want to move ahead 1 meter and move to the left 300 centimeters or something, and you can put that in and it will drive to that point. So that's kind of another neat navigation thing that you can do. But let's see. Whoops, hitting the mouse.
So I saw the Arduino logo. Is that for programming on the ESP32, or is that also for higher level control?
Yeah, you can program the ESP32 just with Arduino stuff, and they give you the code for that. And so pretty much it's one Arduino program, and it supports all the different models, the 2-wheel drive, 4-wheel drive.
Okay, is there a configuration file that you set up for all that?
Yeah, one of the things, like for the selection for mine, I did DIY _ ESP32. And I think there's like 9 different selections that you have there, either to use STL files to build frames, and with the TT motors, either 2 motors or 4 motors, or
Okay.
You can also run the onboard processor as just an 8-bit Arduino Uno. Doesn't have to be.
That's right. Yeah, you've got a selection between an Uno and or well, they say a Nano, but or an ESP32. And if you're going to look at it or do it with the ESP32, it's got so much more to offer than the the Nano. So okay, let's see. Oops, still hitting the mouse. Yeah, this.
They really make this look easy, right?
You've got a
Yeah, they do.
5-year-old training an AI here.
Right. Yeah, and here's the block programming. Yeah,
I think this little
you're
girl has already
downloading the
surpassed my
model.
programming skills.
So easy, even a 6-year-old could do it.
Fun.
So why are we working so hard? We can just do this.
Well, one of the discussions we had last week about this, when you talked about Ray, was what can you do as far as beyond the canned demos that they give you at the application level? What can you do to customize the application? Have you found any more about that?
To customize the application.
Mm-hmm.
Pretty much it looks like you can either write Python code or use the block programming to generate Python code. And there you can incorporate different models. Like it said, it seems to have the most for MobileNet version 1, but they also list, I don't know how many different ones. I saw, I think 3 different versions of YOLO.
But aside from the AI, if you're programming in Python, is the Python program running on the phone, and does it have access to the telemetry coming off of the robot, odometry and such?
It looks like it does, yeah.
Wow.
That one screen that I showed you, it was showing, the distance that sonar reading was seeing, and it knew how fast the motors were spinning, and you could give it different values for motor speed if you wanted to. So you can set the speed of the motors in, it's like 0 to 255, like a 8-bit value.
The Python library that you call to communicate with the robot?
That's on when you download it, the OpenBot app to the phone, that comes up with a screen that's got several different things that you can you can look at and see what's coming back from the robot to the phone and displaying those. So, and then it also lists all the things in the phone that you have access to be able to control the robot platform. Like I said before, this phone has, it looks like it's got 9 degrees of freedom. It's got a magnetometer, a gyro, an accelerometer. What else? Well, those are the main things that I saw. The camera, and you can switch it back and forth, front camera, back camera.
Wow. So in theory, you might be able to make it do 6-can.
Yeah. I'm not certain if, using AI to recognize a can. Yeah, that's kind of a given. I would think you would have to use block programming. I don't know if you could create a model to navigate to the goal or not, if that would work that well. It kind of looked like they had, something similar to Donkey Car, where you trained it on a track, and you had an autonomous mode where you could let it go and it would associate a picture with a steering and a speed.
Yeah, that's why I was probing on the Python aspect to see if you could put logic into it, like the classifier saw a can, now let me tell it to drive towards it and operate the gripper and so forth.
Right, yeah. Well, they showed it tracking a person. So I'm sure it wouldn't be, if only MobileNet had cans in it, but it doesn't seem to have cans in it. So you have to probably create your own, specific model to track cans.
Well, sure, but then you got to do more than that, right? You got to operate a gripper, and then you got to turn around and head back towards the goal where you drop the can off, and none of that involves MobileNet.
That's true. That's true. Yeah, and looks like where the block programming comes in. You can, from the phone, you can, you've got control over motor speed and direction.
So you don't think you can do that in Python?
Say that again.
You don't think you can do that in Python?
I think you can. Yeah. I think they're just using the block programming as a, kind of an easier method to do all that, because, the blocks, there's a block that says, okay, which model do you want to use? And you can throw that in and actually generate the Python code and download that. I don't know if you can download it directly. It seems like it uses the same QR code method to, you scan it with, in case of the Max Cam, you scan it with the Max Cam and it downloads the model. This looks like it's set up similarly, giving you a barcode so you can download, whatever program you created in the block programming. So, yeah, so it looks pretty versatile. Tom, have you played around with it at all? Oh, Tom's not here. Oh, there he is. Okay.
Say that again.
Oh, have you played around with OpenBot at all?
No, not yet. Although it's getting higher on my list.
Good, good. Yeah, it seems pretty interesting. I don't know, there's much better cameras on the phone, on this phone anyway, than on any of the things that I've used so far. Much higher resolution, and
so do you have any idea what resolution the inference engine is actually using on the camera's vision?
Yeah, I think swipe to end. It looks like it's 300 by 300.
Yeah,
and
okay.
I think you can change that. Model. Yeah, I'm not seeing how to do it on this screen, but I thought you could change it.
So the picture quality may have to do with the fact that reasonably current cameras on phones have much better optics than the little tiny cheap cameras I typically use.
Yeah, yeah.
The resolution is probably not the big deal. The big deal is the optics.
Yeah. And it's kind of weird. Yeah, you got a choice, either CPU, GPU, or neural net API. Pretty much I've listed on GPU. I haven't experimented to find out if it's any faster, as far as frame rates on, a neural net API. It's definitely faster than CPU, the GPU setting. And that's the other thing, that you can access, CPU or GPU on the phone.
Yeah, clearly their interface opens up a lot of capability for reusing the technology that's built into phones. I'm really impressed with that.
Yeah, I was too. It was, and I've always wanted to, get into using phones as, as a robot controller, but never really had the opportunity to. So
I encourage people to give me their cast-off phones, so I have a small box full. Now I think I have a use for them.
There you go. Yeah.
Yeah, you might want to notice which ones have a magnetometer and gyro and other sensors, because not all smartphones have all those sensors too.
Yeah. Yep. Oops. Wrong button. Settings. Hold on a sec. Video. Integrated camera. Okay. Anyway, so that was all I had. I hope other people are going to get interested in this thing, and I was, it all came together pretty quick, and made one wiring mistakes with a TB. Well, yeah, I was off. Good thing it didn't destroy anything, but my pin count was off, and so at first I couldn't get the motors to spin, and kind of took a look at it, and I guess you can kind of tell by, I have a lab supply. It shows, voltage and current, and it wasn't drawing any current. So I figured, okay, well, it probably didn't hurt it. Hurt it if it wasn't, drawing all kinds of current, letting the blue smoke out of the center of the chip or anything. So, but fixed that, and everything seemed to be okay. I had to, the sonar prefers to work at 5 volts. I saw something that said that the ESP32 can tolerate 5-volt inputs, but didn't really want to chance it and see. So I put, 2 voltage divider for measuring the battery voltage and for the sonar output, and that seems to be working. And I hadn't used really sonars that much. Mainly because I didn't, kind of my experience was they weren't very, very reliable or accurate. And, but this platform seemed to use one. So I figured, what the heck, I'll 3D print a holder and put it on there. So, but anyway, that's all I had.
Cool. Thanks, Ray.
Yep.
So I've got an update to share on Minniebot. So I got lidar working today. Let's see. Is that showing? Are you seeing? Yeah, you're seeing that. Yeah. And then if you maximize my my video, you'll see Minniebot there, and that's the lidar with the blue flashing top on it. And I believe what it's looking at is the window over here, and because if I move my hand over towards the window, you'll see on the RViz display, my hand is moving and kind of obscuring the window.
Mm-hmm.
And as I move it around to point more towards the closet with robot stuff in, my hand moves out sort of like to the lower side of the robot in RViz. So haven't really totally figured out what it's doing, and there does seem to be a bug in either the documentation or the or the code. I'm not sure which, but what's significant is that the all of this is happening just between the general driver for robotics, for robots, the wave share board sitting on top. So none of this is involving the Raspberry Pi that's located, that's underneath the robot driver board. So now what I'm going to do is drive the thing. See,
Which lidar is this?
This is the LD19. It's a wave share lidar. It's like $60. Or yeah, 60 or 70, something like that. So let's see if I can point that down a little, and the robot's there, and got the joystick, and
So what's on the robot controller board? Is it an ESP32 or another processor, or?
it's an ESP32, and it's using using Wi-Fi to talk to get on my home network, and then using MicroROS as a middleware transport between the ESP32 and my laptop, and then my laptop is on my home Wi-Fi as well, and so the topics published by the ESP32 end up in the ROS stack, and with the exception of lidar, which is where I think there's a bug, it lets me send the ROS command val topic over to the robot, which causes the robot to move, and the robot senses, so things like the odometry and IMU and battery status come back over the MicroROS link. The lidar is supposed to come across a UDP socket back to the laptop, but that's a part that's not working. So when I demoed it lidar just before, I was using a serial connection to the lidar, but when I put it on the floor, I disconnected the lidar, and that's why lidar updates stopped. So what this is showing is really a sub $100 robot, because you don't need a Raspberry Pi in there. Just need the general driver for robots, which has the ESP32 on it, that connects to the IMU, the motors, and the lidar, and sends it all back over Wi-Fi to the laptop for processing. So that was just teleop. Once I get the lidar going, I hope to have ROS navigation working to where it can run SLAM and generate a map of my house, and then navigate between points on the map.
I think you probably gave us the link for the wave share board before. Can you?
Yeah,
repeat it?
I can pop that back up again.
Oh, I'm assuming it was wave share, right?
Yeah, it was.
Yeah.
Yeah, the wave share is a decent board. It's got the ESP32, an I2C expansion interface, which I've got the IMU hooked up to, reset buttons, voltage regulator. So you feed it off. I'm feeding it off of a 3S LiPo battery. USB-C connectors for USB and lidar, motor interfaces, onboard IMU, onboard magnetometer and IMU, motor control chip. That's the most of it. So anyway, I'll be super happy if by next week I can demo it driving around between rooms in my house using RViz to tell it. That's what I hope, and that's my goal.
So Paul, give yourself a gold star.
Oh yeah. Right. Actually, Ray gets a gold star too because he showed wheels turning.
Yeah.
Gold star for Ray as well. So that's all I had. If someone has something else, let's move on to open mic.
Okay, I have some more results from my experiments with GPS if you are interested.
Yeah.
So one of the things I'm really interested in GPS is getting heading readings, because I'm not completely satisfied with what you get from gyros or magnetometers. So I started experimenting with that. And, one of the things I learned with GPS is the accuracy wanders around about an inch per second or so, 1 or 2 inches. And so, if you can move, like, say, 60 inches, 5 feet in that 1 second, then 1 inch side to side error is about plus or minus 1 degree. So I did a little bit of that. Let me present my chart here. There we go. And there's a window. Yeah, I want to do that one. Okay. There it is. And I marked out a line in my backyard at about 353 degrees and walked down it and then turned around and came back. I think down here is where I slowed down and almost stopped. But just my walking speed, walking quickly, was about 5 feet per second. So, and what I'm getting here is 1 or 2 inches of error, or 1 or 2 degrees of error, I'm sorry, as you go along. And the GPS will actually put out the heading error for you, plus or minus degrees. So, and that seemed to correlate with about what I expected. So that all looks kind of good. And obviously, the faster you go, the better accuracy you get. So if you could go 20 or 30 feet per second, you could get it down in the tenths of degrees error. I think I might walk back a little slower here because it was jumping around a lot more, or there's just some other error going on.
Ted, that seems surprisingly good. You were walking, right?
Yes.
That's actually better than I thought it would be.
Yeah, I agree. It was better than I thought too.
Now, I take it you're still running 2 GPSs?
That is still 2 GPSs. I still have the same setup. So, it's green and purple there.
So they're tracking their headings reasonably well.
Yeah.
Huh.
Ted, if you were to use those readings to correct your odometry, using the 2, you may have a fairly stable way to track a compass heading.
Yeah, and what I like is, unlike gyros, it doesn't drift over time and doesn't get further and further away. So that's why I'm interested in there. Also, let's see. Yeah, I lost track of that thought. But
And you
But yeah,
presumably
obviously you have to be moving to do this. That's the one downside. Once you stop it, you lose heading.
Yeah, but that's where your odometry could
Or gyros.
kick in, or odometry and gyros to
Yeah.
you maintain a heading while you're going too slow.
Yep. And obviously, if you know you've stopped, then you don't really have to worry about which direction you're pointing because if you know you're not turning anyway.
So I guess the next step is to see if you can chart the accuracy as a function of how fast you're moving.
Yeah. And that all this experiment kind of here in Colorado depends on what the weather looks like. But yeah, I'm thinking I'll get it in a car and just drive it around the block a few times and see what that looks like at, different speeds going slow or up to 30 miles per hour.
So Ted, is this an XY plot of position?
No, this is an XY plot. It's degrees versus time.
Heading. Sorry, yeah, you said
Yeah,
that.
you have 350 up here and 173 down here somewhere.
Oh.
So you've done basically you walked in like a half circle then?
Well, I walked in a straight line, turned around 180 degrees and walked back.
Oh, okay.
So obviously this was where I turned around.
Were you walking as you turned around, or did you just stop and turn around?
No, I mostly just stopped and turned around. So I don't think it's very accurate here. I may have slowed down and kind of done a half circle. I don't really remember, but the point was I walked all the way to the fence and then had to stop and turned around and walked back.
Okay. But you're saying in the downsloping area of the plot, you don't think that's accurate though?
Well, I think it down here at the end, again, I was getting to the end, the other fence, and I was planning on stopping there. So I think I just kind of lost track of what I was doing and slowed down here, and somewhere here I stopped. And if you stop, it takes a while for the GPS to realize you've stopped, and it'll maintain the same heading that it was on before then.
Do you have a time scale on that as to like what your horizontal divisions are?
Oh,
or vertical divisions?
I dropped, I have the data came from my laptop and I'm on my desktop now, so I don't have the actual data. I just copied the chart. But I think it was, I was walking about 5 feet per second, and this is 40 feet. So that's probably about 8-10 seconds. And then turning around in another. So 2, 4, 6, 8. Yeah, these are probably about 2.5 seconds apart, the lines.
Okay, I'm just looking at it, and I'm wondering if you were to take a sample, and then grab the next sample 2 seconds later, and compare the two, it would give you a pretty good idea of what direction you're going as far as correcting a heading. It's not 100% accurate, but it would still be pretty good to correct odometry and a gyro.
Yeah. So, these, to answer your question a little better, these points are 1/10 of a second apart. But yeah, I see what you're saying, Pat. And that's basically what the GPS is doing for me. It's taking two samples and subtracting their locations and getting a heading from that.
Yeah, so if you look at the same GPS, any of your points, the blue ones, the green or the purple, whatever color that is, when you look at two samples, one after the other, you're a little bit all over the place. But if you look at two samples 2 seconds apart, then you're getting pretty accurate.
Yeah, maybe. What I've noticed with the GPS is it'll tend to drift slowly and just kind of make a random walk if you leave it just sitting in one place. And so I'm assuming it's doing that also if you're moving. So, and that drift was about an inch, between an inch and 2 inches per second. So you're still going to get that drift. But I guess, yeah, the further apart you get, in some ways, the more accurate you get. But you've also drifted more because you've taken more time.
Well, if you could do 20 feet per second, that's 13.6 miles an hour. So not too fast, I think,
Yeah.
But you could get in great shape here doing all this testing,
Yeah.
Never mind GPS. Your camera is going to miss the cone at that speed.
Yeah, probably.
Yeah, I suppose that's the downside. But yeah, if you could get your vehicle traveling that fast, you could get the error down to a few tenths of a degree.
Yeah, I could do 10-minute miles, but I don't know. Not much faster than that.
I could do a 10-minute mile in a car.
Anyway, yeah, the weather gave me an opportunity for one test this week, so that's what I've got for you.
That's interesting.
Okay, would you say that the readings, since they seem to track, well, it seems like they're tracking each other really well. I guess you still, from that, do you think you can still get like an accuracy of what your actual angular position was, or compare it to something else?
Oh, you mean by combining the two readings, you could get better accuracy? Is that what you're asking?
Or maybe having, I don't know, like the B&O 055 or something tell you what, your actual angle was as you were moving.
Oh, yeah. And that's kind of my plan, is to combine this heading information with a gyro, like a B&O 055 or something.
Yeah.
And if you use the right filter, you can combine them so that they help each other.
Mm-hmm. Yeah, that's interesting.
Yeah.
Does SparkFun offer something like that? Kind of a combination, attitude, heading, and reference system plus GPS or something? I thought they might have on one of their boards.
Not that I know of.
No? Okay. Yeah, I'd have to take a look.
But yeah, that's one of the other things I'm working on currently, is implementing a Kalman filter to combine the gyros and GPS, along with the GPS position and odometry.
Yeah, that's pretty complex. I don't know if I'd live long enough to get that working right.
Yeah, I found some Kalman filter examples, so I'm looking at those, trying to figure out how to modify them to do more of what I want, which is tricky.
That's complicated stuff.
Yeah. In the past, I've used complementary filters. So you're just basically averaging stuff together.
That's conceptually a lot easier to understand than the Kalman filter.
Yes, I agree. And if I don't make progress here at some point, I'll probably just go back to doing that again.
I was gonna say, you should have some little hands on servos so that when it gets confused or can't figure out what the best approach to do is, it just throws up its hands like, I don't know what's going on here. Let you know that it's off in the weeds or something, I don't know where I'm pointing.
All right, I guess that's all I've got. If someone else has something, go for it.
I've got a robot I'd like to show.
Yeah. See it,
So
David.
you may remember last year we were talking about education and how we could teach younger people how to build robots and so forth. So I got this little kit out. Let me switch that around. And built this little guy.
So
Oh,
It's called a what?
Cute.
They call it an Odo. I think a Ute is another one similar to it, but it's fairly simple. It has 4 servos, 2 in each leg, ultrasonic sensor, and it's programmable. So if it runs up against something, it'll back up
gives a
and
scream. And
turn around. So it's
So David, is he gonna run in the wheelless there and back this May?
I hadn't thought about that. That may be a possibility. But I'll have to think about that. Let me see here. I was going to show the program. Here it is. Let me see. So the thing that is intriguing to me is it can be programmed in this Blockly, which is similar to what Ray was showing earlier.
right.
And the unique thing about it I like is, let me see if I can get it to do it, is you click a button over here and it'll show you the program in Arduino.
Oh, Arduino?
Hmm.
Yeah. And you can actually, let me see here. I had it going earlier where you could actually show them both at the same time. So a person could look at this and relate it back to how you program in an Arduino. And the other thing I like about it is this Blockly program. It's similar to other programs that kids use. The way I became familiar, I was visiting my grandkids and they were making some little characters run around on the screen, and it was using this same type of programming. So they were, and they are, more familiar with this type of programming than I am. So I hope to get a couple more kits printed out, and I'm going to take it over and experiment with them, and then eventually consider having a class at the makerspace.
Wow.
That's good. I got a ball robot from Sphero, and it uses similar coding technique.
Oh, does it? Okay. Yeah, I was impressed. I mean, my grandkids at the time they were like 6 to 10 years old, and they were just, oh, you wanted to do that? And they would drag a timer over or a do loop and all that kind of stuff. So I think it may be a good basis for younger ones to start getting interested in robotics and programming.
Yes. Uh-huh.
Is Trish still on?
No, I don't think so.
Okay, because I know that Vex had something like this. They had a couple alternatives. There was a C-like program, and then there was a block type program, and I was curious of what I should ask her. What is most common used in their programming?
Mm-hmm.
Yeah.
What age of kids was she working with?
She didn't say, but I'm going to assume that it was the same age that we judged at the VEX Worlds back about 10, 15 years ago, which was high school kids, same as FTC.
Okay. I guess they're using more of the programming language stuff than the blocks, but I don't know.
Yeah.
Well, that was pretty cool. Gold star for David. Walking robot.
Thank you.
Yeah, this is something similar here. Yeah. Can you see that?
Yep.
Yeah, so same sort of thing. There's block programming, and then they give you C code. So in that's using, enable autopilot using mobile command, or you can select on different AIs. MobileNet 300. There's some throwing blocks in there that don't know if this one, I guess those are the only two that you can select between. Anyway, yeah, something similar. I've never really used this or like to use it, but since they give you, translation into C pretty quickly, I might be using more of it. So
Yeah.
Anyway. Anyway, that's all I had.
I think Mark's talking, but we're not hearing. While he works out his audio, I just wanted to say
Oh, there we
thanks
go.
again.
Oh, sorry, Kareem. Go ahead.
I just wanted to say thanks again to everybody who joined and gave them advice last night. And Paul, I saw tons of comments from you as well on the portfolio, and it's kept them busy all day. And we just finished what 3-hour portfolio review session, and it seems to be endless, but. You guys have helped the team tremendously, and just thanks again for offering that.
Most welcome.
Yeah.
Most welcome.
They did a great job.
Yeah, they're really amazing. But you got some competition now, Kareem. Before you joined, Trish Cook was on asking for us to help her with essentially the same thing, interviews and notebook reviews for VEX.
Yep, the demand could, I'm surprised. I'm surprised we haven't been tapped by more people, but yeah, we've appreciated everything that we've gotten out of it, and I guess I have to make the yet another appeal. Regionals is forget it. Regionals is the same day as your meeting. It's this weekend, so same day as your meeting. So we can't ask you to be judges. right? Otherwise, I'd be at the monthly meeting.
Oh, it's on Saturday.
Yeah.
Oh, regionals is on Saturday.
Yeah.
Yeah.
Cool.
We got Doug talking on how to use KiCad, and I'm very excited about that.
Yeah, same.
I hope you're gonna record it.
Oh, yep, for sure.
Anyway, so yeah.
Break a leg.
Thanks. We probably will. In the wrong way. You know, it'll probably feel like that by the end of the day.
Actually, there's a pretty decent tutorial that I've been working my way through on KiCad. Trying to get to where I can ask Doug some hard questions.
Well, I've been working on my that little robot, which is basically just a motor turning a frame of art. And I realized that I needed a remote control, because once you put the art on the motor, you can't access anything behind it to turn it on and off and change the speed. So I found something online that has I'll try to do this. Has a remote control, has 4 buttons, and it controls the motor. So let's see if I can show it on the wall here.
Is this for Mother Robot, Mike?
No, this is just a little thing that rotates. That will rotate a piece of art on the wall.
Oh.
And so I'm not sure if you can see it, but right there is a receiver. And so I squeeze it on the board and got it working. And I have the oh, my mouse is disconnected. Okay, and I'll share the information about it. Yeah. So.
Oh yeah, 433 megahertz. Just.
Yeah. So is this LoRa?
I don't think they're LoRa.
Okay. Okay.
Yeah, they've been out for quite a while. There's 433 is pretty common.
Yeah, so it's pretty cool. It's a little teeny module and had 4 buttons, and it just worked. I was happy about it. Yeah.
Yep.
I didn't want to design anything, so yeah.
Yeah, did you have to press a button on the receiver and press a button on the remote to try to get them basically tuned into each other?
I had to press it to get them to talk to each other, and and then you press a button to change different switch modes, where it's momentary or latched or stuff like that. So
or toggle or things like that.
Yeah. So so that's a little side project I'm doing. Can't wait to get back to a robot.
Yeah, I use something similar on an alarm system, and after a while, it seems like they, I don't know, get detuned or something. They're
oh no.
So you occasionally got to refresh the tuning, and it seems like it comes back, but it the older the module gets, the more it drifts. So
hate to hear that. Yeah.
Yeah.
But the remote was really nice to have just a nice remote. It's all for like $10, 15. Yeah. So
yeah,
perfect. Mm-hmm.
Hey, Doug, I've got a question for you that pertains to everyone. Are you still on?
He's lurking in the dark shadows.
Uh-oh. We may have lost Doug. I guess
I see a square on the screen.
Okay.
Maybe
It's in a
he's in the
dark place,
canyon.
Well, maybe I'll ask it anyway and see what you guys think. Something we talked about after the last Roborama was maybe we ought to add a point in the rules for out and back if your robot turns around. So there's like one point of it ends up in the big square and another point of it ends up in the little square or something like that. But have another point for if it turns around, because it's a heck of a lot harder, as David Anderson pointed out, to get it turned around and pointing back in the other direction than, and I think Doug would have won the last legged contest if we'd have had that in place, because his robot actually turned around at the far end. Because then you got to like maintain heading accuracy as it does at 180.
Yeah. You better define when it has to turn around, though.
Well, at the far end, when it like
okay,
it's an out and back. So yeah,
and how much turning it has to do.
Well, I don't
It
know.
can do that. It could do that. It could turn. The problem that it had, in fact, we actually did an acid test because we ran it into the wall, because the thing that it couldn't do, because of the gate that I was using, is determine how far it had gone. Okay, so it would overshoot, but even hitting the wall, and then I think David Anderson actually tried to help it out, but he put a chair in front of it or something, and it got all around all of that stuff and headed back. It just, but distance it had no concept of.
So Doug, what do you think about the idea of adding an extra point in the out and back rules for robots that turn around at the far end?
Well, okay, this is a question of whether or not. Okay, when we first started running it, all the robots turned around. And then Carl came in and ruined it by doing just a zip in and zip out. So what I'm trying to say is,
it was always called Quick Trip. I can tell you that there were in the deep dark past when it was first. Are we talking about Quick Trip?
Yeah,
because that's been around since like we were at the Perot.
Yeah, Kareem's right.
I mean, that's been around forever.
Right.
And there's been other robots that have gone backwards.
Yeah.
Before.
So Paul, if it rotates 4 times, does it get 4 points?
Exactly. Like the amount of rotation, does that matter? It's like, but my question is more along the lines of maybe that's a different contest or a different level in the contest or something like that. Because the whole point of Quick Trip was to be the simplest possible thing somebody could get started with. That was the original intent.
Oh,
now we're
I didn't
free to
get
change
that.
the intent, but that was the original intent when it was first designed.
I
thought it was more fun to pirouette on the way and come back. That was a
Well,
lot more fun.
that's a nice flex. Yeah,
I thought
absolutely.
that's the way you would do it, Carl. Never mind turning around.
I did it
just
that way.
pirouette there.
I did it that way because it can't be simple.
Well, I don't know that it really takes away from it being the simplest possible contest to say that you get an extra point if you do turn around. It doesn't mean you have to turn around.
Sure.
Well, then Paul and these other guys came by with legged robots. I mean, the world's just going to pot.
Yeah, I guess my thought is I would leave the rules the same as they are, because some people, I think if I were to run it, I'd probably turn around anyway, because my robot doesn't run backwards so well. You know what I mean? It wouldn't run that distance backwards so well. But some of the other robots was able to do that without any problem. I mean, that's a skill too.
I might turn around 360 just to be ornery.
And go, oh yeah. Well, I'm just saying is, so I think I just leave the rules the way they are. We have a new classification for non-wheeled robots. I think that's for people who want bigger challenge. That's definitely a bigger challenge. And pretty flexible too. Now the big question, since I've got my rule nayers here, is a Spiro a wheeled robot?
Interesting.
Yes,
I guess it is.
Yeah, one wheel.
Okay, I'm just
It's
saying.
got wheels.
Well,
It's got
what's a
multiple wheels
wheel?
on the inside.
Yeah, it has multiple wheels on the inside. So yeah.
Yeah, but what touches the ground? I guess my thought would be it's a one-wheeled robot, but
Oh, now the Google AI says technically a wheel is not typically considered spherical. So saith the AI.
yeah.
That shows us.
Yeah, well,
God forbid the AI's wrong.
All hail the robots.
Oh yeah, I could
Oh, wait a
enter
second.
my Spiro in the contest as a wheeled robot. Yeah. Yeah.
Probably not as a legged one though.
No.
Yeah.
So is a frisbee a wheel?
Could be.
Give it an axle. What about a gear? Like one of
Wait a second. Do we even
Pat's
have a
favorites-
wheeled category?
Pat's favorite saw blades, maybe.
Is there even a wheeled category?
Well, there's just quick trip.
There's a legged category.
Yeah.
But quick
I don't know if
Trip
that's the
has to have
question. I
wheels.
don't know if the category is labeled legged or non-wheel. So you could say there's a difference there. A non-wheeled robot is probably a bigger class than just legged robots.
Yeah, like a flying robot. Yeah.
Well,
There was a guy way back when who had a robot that would waddle. It basically had a turntable at both ends, and it would lift up the far end and then twist on the turntable, and then twist 180, put that end back down, pick up the other end, and twist it 180. That happened in DPRG way back when.
Huh.
yeah.
I don't know what category that would fit in.
What about the inchworm bots?
Yeah.
I think we'll just call it's a leg robot contest. That category. So it has to have legs.
4 legs or 3 legs or 2
Nope.
legs?
Yep. You can have one leg and hop if you want to.
Okay.
So are we going to do a legged robot contest at Roborama?
Yep.
You could.
And hopefully we'll see some non-pie dog ones, but we'll see.
What's the idea of getting Roby to work? Robbie?
When he's working, he's a real eye catcher. I guarantee you stop a crowd, when they come by. They'll all give him a gander. I think
what will it take to get it to work again?
Just a couple laser cut parts.
Oh.
It'd really be up your alley, Mike, in the sense of the programming now. He has one shoulder which can rotate, and I think and he has wrists that can rotate, and that's all he's got. So he has one hand that's posed statically and one hand that can go up and down and or out. It can go out too. And I don't know. That one, we might have to test it to make sure it goes because it has fish line as part of the mechanism.
Hmm.
So
That was
the idea of resurrecting Roby came from the idea that for the April meeting we would do a robot exhibit, robots running around doing stuff, sort of like Moon Day at DMS, to coincide with their open house that runs. I think you said noon till 5, right? Right,
Yeah.
Mark?
Yeah.
Yeah. So and so when we were tossing around that idea, we thought, well, if we resurrected Roby, he's a real, as Doug said, a real eye catcher, to attract people in to see our robots.
Sounds like it's time for its, semi-annual maintenance update. Replaces fishing line and
well. Hopefully, we don't have to do that.
blow the dust off.
Blow the dust off. But hopefully, the dust has given us enough friction that we won't have to screw with the fishing line. That arm joint was the work of God, I can't think of his name now. Don't die, guys, because you pass away and nobody remembers you. Who is
Ron Grant?
No, he was a buddy of Ron Grant's.
Oh,
he was very elderly.
yeah.
His attack, huh?
Ralph?
Will.
No, not Ralph.
Yeah, I can't remember his name. I know who you mean. He had a
little mustache. Anyway, he was a mechanical engineer. So that shoulder, he gave me make a space this big for the shoulder, and so when I was building the chest, I made him a space the size that he specified, and he made this. I mean, it's a ball joint. It's real. I mean, it's really something to see. It'll never. The idea was that someday Robbie would have 2 of them, but that never occurred.
Well, can you get the one shoulder joint, doing, something to music, boom, 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 boom.
Well, that's a good idea. That's where we need to have Mike come in and program something like that. It's not very fast, but you could move it about like you were doing, Ray.
Do it maybe 1/4 beat, he's boom, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4,
And he had I want to say we put speakers in the body so that there would be the program that existed would said random things, sort of like big text. And one of the things it said was, please step away from the robot. And these little kids, you could see their eyes get big. They'd go up. They were going to touch it. They're going to touch it. And Robbie would say randomly, don't touch the robot. And their eyeballs would really get big and they'd step back. It was amazing because it was just serendipitous, but it was pretty cool when it happened.
Oh, if he's got sound capability, maybe you could do the wet fart thing. The guy in New York City that farts in front of people that are walking, and just pretends that doesn't acknowledge it or anything.
Well, I have one of the farting robots. It was.
Oh, you do?
Yeah, I do. I just picked it up at one of the Goodwill stores for a couple bucks, and it's funny. The plates that cover the rear end of the robot flap up, when he makes the fart, and it's kind of it. And he's got a little dialogue that's kind of cute.
There you go.
It was obviously made for 8-year-old boys.
I can see that.
Overtired guys. Yep.
So
But yeah. So as for the arena, the sumo arena, I dug it out of storage. So
yeah.
Cool.
It's way bigger than a mini sumo thing. It's 42 inches across.
Yeah.
And I think mini sumo is supposed to be around 30.
Oh, is that foam? Is it made out of foam?
Just pink foam.
Yeah, that's not that's
foam, so I made a 30 inch. Sorry, Queen, go
oh.
ahead.
The foam one is for plastic fastener sumo for the kids.
There's Mark, there was a high grade sumo ring that we had at one time. I don't know if we still have it, but so you might have to go dig some more. Now I think it's smaller than that Pete roll one, but I don't know how. I don't know. It's not real tiny. You know, it's probably 30 inches or something like that.
But did you say you'd made one?
Yeah, well, I had a lot of pink foam here at the makerspace, so I just cut one on the hot wire and painted it just now. So
okay, well, that's cool. That's even better, Mark.
Yeah.
Yeah, but yeah, no, I saw that. I mean, that one was standing up like on the display. So I was like, oh, there it is. Pulled it out. Didn't think to look anywhere else. So when I put this one back, I'll have a look for that fancier one. Doug.
Yeah, yeah, it's made out of wood. You know, wood. Got real paint on it.
There.
Yeah.
So we got a real arena for a mini sumo contest, and it sounds like we're going to have two competitors, Scott and Mark, at a minimum.
What if I can code it in time?
Yeah.
Yep.
Did the kit not come with some kind of code?
It came with samples of all the sensors and motors. So like there's a motor test, there's an IR test, there's an approximate, but nothing like linking them all together to like go into battle, as it were. So I've just got to figure that out, and then we'll see. Hopefully, fingers crossed. You never know. I'll see if the old AI can assist.
There you go. Chat GPT, help me out.
Tell it. Your prompt is, I need to beat Scott Gibson in mini sumo. What strategy should I use?
Or Scott would say, I need to kick his ass.
Yep.
So Kareem, do you? I guess you don't have any of your sumo robots left, huh?
We still teach them every time we do a big, like they were there at Frontiers of Flight. We were teaching kids to code sumo robots.
So are you or any of Iron Rain going to maybe come and compete in mini sumo at Roborama?
Oh, probably not. I don't even know that you guys are doing the plastic fasteners division.
No.
That's a different thing.
No.
And we don't have any. Again, I had some mini sumos from way back when. I haven't seen them in a while, so they're kind of lost. I haven't seen them since we moved, right? So probably not.
Harold's the sort of guy who would build a mini sumo robot. He builds all kinds of things.
What's the objective of the mini sumo contest?
To push the other robot
off the ring.
Ah,
yeah.
Kind of like sumo wrestling.
But automated.
Yeah.
A little less ceremony.
Would there be more competitors if there was a legged sumo division?
Little pie dogs pushing on each other.
I'm just asking. I'll put it out for discussion and see what happens quietly in the corner.
There's just like 3D print a little sumo wrestler to sit on top.
That's something Ron Grant would do with a little hand out there. It comes out and slaps you or something.
Yeah. There is a spare I squared C port on there, so maybe. Yeah.
Ron's got all kind of little animatronic plastic hands. It's You could give Tate McKinnon a run for her money. But yeah,
Print it in TPU, make it floppy.
right. Hot dog fingers.
Well,
Bye, guys. I gotta go.
we're losing status, losing momentum. So
Losing steam.
we'll
The
close-
freeze
we'll
this
close
year.
it. Okay. See you guys. See you guys on Saturday.
Night all.
Yep.